It's better than magic. These middle school students spent several class periods creating powered, mechanical flying machines from scratch. They've had to work carefully and trim off every gram of extra weight. There's nothing like it. They are releasing something they made with their own hands and watching it soar above their heads. Dreams of flying can come true. I've been experimenting for years, looking for an airplane design that would really fly. It had to be simple enough to build that my 6th grade technology students could make it as a first project in a few class periods. This is still a challenging project. You might have to do steps over again until you get it right. But in the end, everyone gets into the air, and many students' planes fly so high that they bump into the very high ceiling of our school's auditorium.
Recovered.
We've learned that there's no telling what's going to happen when we fly our planes.
Oh.
We expect the unexpected. And the hilarious. And the disastrous.
Whoa, I was looking through the monitor, all of a sudden. Oh, there it goes again. Yay! Oh.
It's all part of flying. This video presents step-by-step directions for making a model airplane that really flies. I'm going to ask you to do it my way the first time. That means following the directions closely and not doing anything that the directions don't say to do. Once you get a plane in the air, then you can experiment and innovate. The instructions are broken into steps. Some of the steps are long and some of them are short. I think it's important to watch a step through to the end of the step. If you don't see the whole step before working on your airplane, you might miss out on important details until it's too late. So how do you know when a step is finished? You'll see the video of the step reviewed in fast motion like this.
And you will hear me talking like this.
And of course, when the instructions are not clear, simply click on the playhead and drag it back a little to see that part again until it makes sense. And drag it back a little to see that part again until it makes sense. You're ready to start building the airplane. Go to part 2, propeller and fuselage. The propeller is the only ready-made part that we'll use. It's incredibly efficient. Blow on it a little bit and it'll turn. If you hold the propeller upside down and hold on to the round metal part like this, you can see how the propeller spins freely in one direction but catches in the other direction. That kind of mechanism that allows freewheeling in one direction but engagement in the other is called a ratchet. Perhaps you've seen a ratchet wrench, which can be set for one direction or another. If you look closely here, you can see how it works. The tip of the black propeller has sort of a ramp that either catches or slips on the metal part. We cut the rubber band from a giant 50-foot piece of rubber band. And you need to cut it to 12 inches unstretched.
Check out the propeller ratchet and cut 12 inches of rubber band.
The knot we use to make a loop in the rubber band is called an overhand knot. It's an easy knot, but it's more confusing because you put two ends together before you tie the overhand knot. You just sort of put the two ends together and pretend that they're one piece. Just make a loop and push the end through. Tighten the knot a little and notice that we have a problem. This loop is too small, and this end is just wasted rubber band, dead weight for the plane. You can solve both problems at once by moving the knot. You do it by grabbing and spreading the loop part of the rubber band. That way, you can actually move the knot toward the end and make the loop bigger. Move the knot until it's close to the end.
Tie the rubber band into a loop and move the knot toward the end.
A 12-inch long piece of balsa wood is the fuselage or body of the airplane. The smallest spacing on this ruler is 1/16 of an inch. 2/16 of an inch equals 1/8 of an inch. And the other way, it's 1, 2, 3/8 of an inch. 1/8 of an inch by 3/8 of an inch is a tight fit into the cup of the propeller. It can be difficult to get the end of the fuselage to fit in. But if you push the corners against the table a little bit, it's much easier to get it in. If you have trouble getting it all the way on, push it against the table, but let the propeller hang out over the edge so it doesn't get bent in the process. But don't hold it far away, or when you hook the rubber band to the propeller, the knot is always away from the propeller. If you look closely, there is a space where you can slip the rubber band in. If you don't mind holding the other end, you can wind it up now.
Attach the propeller to the fuselage and hook up the rubber band.
There are lots of ways to hold the other end of the rubber band. Using a piece of a small paper clip works well. Don't use a large paper clip. It's too heavy and it's hard to bend. Straighten the paper clip enough to get a 1-inch piece from it. Mark it at 1 inch and cut it with a pair of pliers. Look at the pliers to see where the cutting part is. Once you have a piece cut off, bend one end around so it's not sharp. You decide where to put the rubber band holder by how much the rubber band stretches. If the rubber band is stretched like this, there will be too much friction in the propeller and it probably will not fly. At the other extreme, if it's loose like this, it'll take forever to wind up. So the rubber band should be straight but not stretched. Hook the sharp part of the paper clip into the rubber band loop and poke to mark the fuselage where it will go in. Then lay the fuselage on a table to back it up and push the paper clip all the way through. Notice that it came out the side, and that's okay. Just patch it up with some hot glue to make it stronger. There is a trick to getting strong connections with hot glue. If you just lay a blob of hot glue on a piece of wood, it'll sort of stick. But with your fingernail, you can just knock it right off, and no trace remains. But if you can smush and push the glue into the wood fibers when it's still soft, the glue gets a good grip on the wood. Here, the best I can do is try to slice off the glue with my fingernail. But even then, there's some glue that I cannot get off. It's grabbing too hard onto the wood fibers. So glue the rubber band hook into the fuselage and push the glue into the wood fibers. Let the glue cool and harden for a minute, and then consider which way to bend it. If you bend it toward the propeller, do you see what will happen? That's right. When there's tension in the rubber band, it'll slip right off. So we bend it away from the propeller to hold it on. But look what happens when I put some tension on this rubber band. It looks like it might pull out. Use your best judgment to decide how much glue, if any, you need to strengthen that hook so it doesn't come out.
Cut off a piece of paperclip. Bend one end. Push and glue it into the fuselage.
Congratulations, you've finished the fuselage. Before you go on to the tail section, let's look at why you wind up the propeller in one direction and not the other. As you face the plane like this, you wind up the propeller clockwise. So named because that's the direction the hands on a clock go. But why? Propellers propel planes through the air for the same reason that rockets, including water rockets like this, move forward. The principle is Sir Isaac Newton's third law of motion, which says that for every action, there's an opposite reaction.
2, 1!
In a water rocket, compressed air in the bottle hurls the water down. That's the action. So guess what direction the bottle goes as a reaction?
I got you, Jimmy!
Of course, with airplanes, there's no water, but the propeller is making something go backward. What is it? If a propeller pushes enough air backward, it will pull the plane forward. By the way, students often ask me at this point, can I fly it now? Just the fuselage without any wings or tail section? My reply is, sure, a rock will fly if you throw it hard enough. The tail section of the plane, which includes the stabilizer and the rudder, is built on this pattern. Cut a piece of tissue paper so it's big enough to cover the stabilizer and the rudder patterns. Tape it down, but make sure you don't cover the pattern with the tape.
Rough cut and tape a piece of tissue paper over the pattern.
When you build the balsa wood frame over the tissue paper and the pattern, it doesn't matter which piece of balsa wood fills the corner. You decide, but do fill it. Don't leave it open like this. The way I'll demonstrate it is with the top and bottom pieces filling that space. Mark where you're going to cut. I find that scissors work as well as anything to make the cut. Since the top piece and the bottom piece will be the same size, you can use the first piece of balsa wood you cut to cut another piece the same length. We'll use a sticky glue stick to glue the balsa wood directly onto the tissue paper. Make sure you get the glue on all the way from one end to the other. Make sure the balsa wood is exactly in the right place before you push it down hard, but then do push it down hard so it stays. When you're using the glue on the balsa, if you're not thinking about it, you can make an awful mess out of the glue stick. It doesn't just look bad, it's hard to use the glue stick when it's like this. I'm sort of exaggerating here, but do try to rotate the glue stick every once in a while so you're not creating a rut. When you get the top and the bottom on, then figure out how long to make the side pieces. For the way I've done it in this demonstration, I have to cut them so they fit exactly in between the top and the bottom. Laying out the frame for the rudder is almost the same as laying out the stabilizer. It's just smaller and open on one side.
Cut balsa wood to fit the pattern. Glue the balsa wood directly to the tissue paper. Try not to make ruts in the glue stick. Get a hot glue gun plugged in for the next step.
Mark the middle of the stabilizer. Later, that's where the rudder will attach, and it's got to be right in the middle. Remember that the secret to getting good glue connections is not to use big globs of glue, but rather to spread the glue around and smush it into the fibers. Get the glue on the balsa wood, but also get it in the inside corner to make the glue connection strong. The technical name for an inside brace like this is called a gusset. Glue all 6 corners.
Mark the middle of the stabilizers and glue the corners.
Carefully rip off or cut off the tail section from the pattern. When you cut off the extra paper, cut it very close. And it's not just for looks. The plane will actually fly better if the edges are clean. Less drag, less air friction.
Take the tail section off the pattern and cut off the extra paper.
In this step, you glue the rudder onto the stabilizer. There can be a problem if the bottom of the rudder is not straight. But if you gently pull and stretch it as you glue it on, it makes it straight. Once you put a dab of hot glue here and here, you don't have much time to work until it hardens. Do not add any other glue in between these dabs of glue. Remember, right now you're just tacking it on. As you're waiting for the glue to dry, gently pull apart the ends so that the rudder stays straight. Add a little more glue and spread it around to reinforce and sort of tie everything together. As that glue dries, make sure that it's perpendicular, not leaning off to the left or the right. If there's some twist in the rudder, now's the time to get rid of that too.
Using glue on the balsa wood part, glue the rudder and stabilizer together.
The wing is so big that you have to cut out the halves and tape them together. Cut very carefully on the single lines because that's where the two halves tape together. Just rough cut outside the lines for the other sides. Obviously, the two sides have to be aligned. Sometimes it can be hard to see the misalignment unless you look at it from the end. That's more like it. Making the wing is just like making the stabilizer, only bigger. Tape the tissue paper to the pattern. Make sure not to get the tape where the balsa wood will go. Once again, cut the balsa wood to fit. You decide which pieces fill the corners. I push the balsa wood onto the glue with my thumb because the planes don't fly well if the paper starts to peel off. But remember to turn the glue stick every once in a while so you don't make a rut.
Cut and tape together the pattern. Build the wing on top of it.
It's important for the wing to be flat. Before you glue the four corners with hot glue, I suggest that you put something down on top of the wing and keep it there until the glue dries. Before you separate the pattern from the wing, mark the balsa wood in the middle of the wing, just like you did for the stabilizer. Cut the wing free from the pattern. Once again, when you cut off the tissue paper, it's important to get it close. There have been planes that we could only get flying by cleaning up the wing. If you can't cut close enough, try rubbing the edge with a glue stick and push the paper flat.
Glue and trim the wing.
One of the good things about this plane design is that it is very stable. It achieves the stability with a dihedral or angled wing. You can see the V shape of the wing here. It's actually easier to build the angled wing upside down than turn it over. To achieve the dihedral, we crack, but don't break, the balsa wood in the middle of the wing. This is breaking. The balsa wood actually separates. That's not what we want. This is cracking. The balsa wood stays together. That's what we want. It's a good idea to dent the balsa wood with your fingernail first. So the balsa wood cracks at the right place. Notice that the crack opens on the balsa wood side of the wing, not the tissue paper side. To put it another way, when you crack and bend the wing, make sure that the balsa wood side is on the outside of the V, and that the tissue paper side is on the inside of the V.
Crack and bend the wing.
When you glue the balsa wood back together at an angle, The peak should be about 3 inches above the table. It's a good idea to put something at the end of the wing to hold it in place. Cut a piece of balsa wood about 4 inches long. In the next step, you'll glue this 4-inch piece across the wing. The wing is not scrunched up like this. Rather, spread it out a little bit. Put a little dab of hot glue on the balsa wood at both peaks and quickly glue the balsa wood across before the hot glue has a chance to cool. Notice that a little bit of the balsa wood hangs out on each side of the wing. As the glue cools, make sure that the peak is still 3 inches off the table.
Cut and glue balsa across the wing.
Notice that the wing is several inches higher than the fuselage. They are connected by 4 thin toothpicks. The toothpicks are glued to the wing, but taped to the fuselage. There are 3 advantages to this system. The taped fuselage connection allows for easy adjustment. The high wing is stable in flight, and you can take the wing off and put the plane in a shoebox for safe transport. I used to glue the toothpicks on one at a time. I would put a dab of glue in the corner and twist the toothpick into it. Then I would try to hold the toothpick straight up while the glue hardened. And you can still do it this way if you prefer. However, it was a difficult step. Now I think we have a better way to do it, which is to glue 2 toothpicks together first. That makes them parallel and gives them the perfect spacing. The fuselage has the perfect spacing, 1/8 of an inch, so we're going to use the end of the fuselage. The toothpicks have a fat end and a skinny end. Press a toothpick against the fuselage so that the fat end of the toothpick hangs over the end of the fuselage. The fat part of the toothpick should hang out over the end 3/8 of an inch. You can gauge 3/8 of an inch because the wide part of the fuselage is 3/8 of an inch. Tape a toothpick on the edge of the fuselage, flip over, and tape another toothpick the same way on the other side. Tack the toothpicks together with a small dab of hot glue. The small dab of glue should create an H shape. The glue should be right in the middle. It should not glue the toothpicks to the fuselage, and it should not go to the end. There needs to be a notch here. When you take the tape off, this is what you should see. You need 2 of these assemblies, a total of 4 toothpicks.
Glue toothpicks together.
The toothpick assembly goes right in the corner against the other wood structural pieces. The notch in the toothpick should fit right onto that piece that goes across the wing. When the toothpicks are glued on, they should be vertical. stand straight up. If you're not good at judging vertical, the 90-degree right angle of a piece of paper might help you gauge it. As always, the goal of hot glue is not to put gobs and gobs of glue on. Rather, it is to use a small amount of glue and spread it around with the hot tip of the hot glue gun. Before the glue completely hardens, make sure that the toothpicks are standing straight up both ways. Glue the other pair of toothpicks on the other side of the wing. Before the glue hardens, make sure that all the toothpicks are going in the same direction, vertical. Wiggle the toothpicks. Is the glue connection strong? If not, spread around glue until you have strong glue connections.
Glue the toothpicks on the wing.
With the fuselage, tail, and wing finished, it's time for final assembly. The tail section will be even with the end of the fuselage, not sticking out like this and not recessed like this, but even like this. The rubber band must be on the bottom of the airplane, and usually the tail section is glued on top. If you glue it on the bottom, it'll still fly. It may look a little funny, but it'll still fly. Once again, it's 2 dabs of glue at the balsa wood part, no glue in between, and work quickly because the glue dries quickly. These sides should be parallel to the rudder and perpendicular to the stabilizer.
Glue the tail section onto the fuselage.
The toothpicks are going to straddle the fuselage. The question is, where does the wing go on? The answer is, at least at the start, 3 inches from the front of the plane. And by front, I mean the front of that white plastic thing. Make a mark 3 inches in. Unroll some electrical tape and measure off 2 inches. Slice the 2-inch piece of electrical tape in half, that is to say, the long way. Then cut those long, thin pieces in half crossway. So you have 4 thin 1-inch pieces. Line up one of the sets of toothpicks with the 3-inch mark. The front set of toothpicks should be even with the bottom of the fuselage. Press the tape on. It ought to be about as wide as the fuselage. The back toothpicks go lower than the front toothpicks. We make the back of the wing lower to give it a slope relative to the fuselage. This is called an angle of attack, and it helps the plane climb up in the air. To start out, the toothpicks should stick out about 3/8 of an inch, which, remember, is the width of the fuselage. You can change this setting later. Rub the tape pretty hard with your thumbnail to make sure it sticks. Turn the plane around and do the other side. After all that work, your plane is finished.
Mark the fuselage 3 inches from the front and tape on the wings.
This section is about straightening propellers when they get bent. Notice I didn't say if they get bent, but when they get bent. Your plane will hit things, and the propeller will get bent. And your plane will not fly well until you straighten the propeller. Like any other skill, it'll be challenging to learn, and then much easier once you get it.
That's stalling. Oh, your wing stalling.
Go, go!
I hold the plane in my hand when I straighten the propeller, but for a steady demonstration, I've clamped it into a stand. Tip number 1 is always wind up 20 times before you start to straighten the propeller. You do it so the propeller is being pulled in, making it far easier to work on. There are 2 ways a propeller can be bent. The most common way is like this. Notice that the blade is at this angle, and then half a turn later, it's at this angle. The trick to getting it straight is bending it in between these 2 extremes. It will take a lot of practice, but keep fiddling with it and you'll get it. There's another kind of bend that is not as common, but if your plane takes a really hard crash and the propeller gets hit in the middle, you get a sideways bend. You can look at it from the front, but I think it's easier to look at it and bend it back straight from the side. Notice from this side view, the propeller seems fat, but turn it just half a turn, and it seems skinny. To get it straight, you have to twist the propeller until both sides seem as wide as each other. There's one more thing that can happen to the metal propeller shaft. Do you hear that clicking sound? Can you see what causes it? It's the hook bumping against the white plastic thing. Once again, it may take several tries to get it bent back right. And as with all the ways of straightening the propeller, make sure you wind it up first to put some tension on the metal thing. We already talked about which way to wind up the propeller, as the plane faces you clockwise. I think it's easier to wind the propeller if you hold the fuselage close to the propeller, not way back by the tail. Also, where your finger touches the propeller can make a big difference in how fast you wind up the propeller. If your finger's near the end of the propeller, it has to make a pretty big circle for every turn. So the winding up is pretty slow. But if your finger is near the middle of the propeller, the circles are small, and you can wind up faster. The next question is, how many times do you wind up the propeller? Most people do not wind up the plane enough. The answer is that you should wind up the propeller at least 200 times. That doesn't mean that you'll always have to count how many times you've wound up, but the first few times you should count. Then you'll have a feel for how far to wind it up. By the time you get to 200 turns, it'll have lots of triple knotting all the way across. And when you get to 200 turns, you'll feel the propeller really pushing back against your finger. When you launch the plane into the air, launch it gently at a slight upward angle. Remember that the plane has its own power. It's not like throwing a baseball or a rock. If you throw the plane too fast and/or launch it at too steep an angle, it will first stall and then crash, especially if you don't have it wound up enough.